Welcome to this video where we are going to talk about the approximation of the integral using left hand points, right hand points, and midpoints. Here's an example where we don't give you a graph like before. We give you an integral and we are asked to approximate it, and we usually are given the number of subintervals. In this case it's 5, and the method. In this case it's right hand points, but I will mention left hand points and midpoints as well. Okay, so what to do with the integral, and what is all this notation even mean? Solution. The notation of the integral means that there is an integral. We're integrating a function f of x. dx is part of the notation of the integral. And what's important, it is the interval is happening from a to b, right? So now we can write down the interval. So a is 0, b is 4, interval is from 0 to 4, right? And f of x is x cubed minus 5x squared plus 6x plus 5. And now you can basically do what you did in the previous examples. Solution, well, I already wrote the solution, so I like to write down steps, right? Steps. Step number 1, find dx. dx has a formula, b minus a over n. Okay, yeah, we just wrote down what b and a are. It's 4 minus 0. What is n? N is something we either choose by ourselves or we're given. N equals 5 in this case. So we'll put it in different color. So this is a step size. The step size ends up to be 0.4. Step size. Again, if n is 100, then the step size will be 4 over 100. So the bigger the n, the smaller the step size. And the smaller the step size, the better approximation is. Put this in the box because that is going to be important for the formula. Now, step 2. Steps. Step 1, find delta x. Step 2, now figure out the point. So I like to make a sketch for students. Here's the interval. It's closed interval from a to b, from 0 to 4, where 0 is a and 4 is b. Now we know that we're dividing this interval by 5 and the step size is 0.4. So the first point, which we may call a sub 0, or let's call it x sub 0, the first point, while the last one x sub n, and then we'll have to figure out what n is. N is always one more than the number of intervals. We know that number of intervals is 5, so it's going to be x sub 6. And I'll prove it to you right now, just in a second. Well, actually, it depends how you start, from 0 or from 1. So we'll see it in a second. So the next point will be here. It's 0 plus 0.8, 0 plus 0.8. You do a plus delta x. That's how you calculate a new point. X sub n is x sub 0 plus the step size, right? So the next point, so we're going to call it x sub 1. The next point is 0.8 plus 0.8. That's 1.6. That's x sub 2. Then the next point is 2.4, 2.4. That is x sub 3, and obviously I did not plan well. Oh, actually it's fine, just one left. Check it out, almost fits. The next point is 3.2, and that's going to be x sub 4, and the last point, x sub 5. We will have number of points is one more than number of intervals, because interval have two ends, right? So for one interval, we have 2 points, right? So it makes sense. We had 5 subintervals, and we have 6 points, x sub 0, 1, 2, 3, and 4, 4 and 5. The last point is 4. So this is my list of points. And now I can start with actually calculating everything. Methods. If, in this case, we're asked to do right endpoint method. So the notation is R. Actual notation is not very universal. ISO A sub R, ISO R sub 5, because there are 5 subintervals. The most important is to remember the formula. You have delta x always in front, and then you have a function. And you start with not the first one. You skip the first one, because you only can use right endpoints. Let me put it in bright yellow. Right endpoint is 0.8, right endpoint for the first interval, and 1.6, and 2.4, and 3.2, and then 4 right endpoints. So you start with x1 plus la 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 la, and you finish with the last one, and that's actually very important. xn, right? So xn, well, in this case, let's even write it down, x5. So this is last one. How do we do that? Well, we know delta x, so we can put it in the box. That is actually a formula. Look at that, looks beautiful. No beautiful box. Okay. Can we? Okay, thank you. Okay, so we have delta x. Delta x is 0.8 step size. Then f is, I wrote it down f for you over there. Look at this, beautifully standing over here. It's a cubic function. So cubic function, and you plug in the first point. And the first point is not starting with a. It goes like this. So 0.8 we plug into cubic function. So it's going to be 0.8 cubed minus 5, 0.8 squared plus 6, 0.8 plus 5. And that's only the first number. And then plus. And then guess what you plug now? Can you tell me? Correct. 1.6 cubed minus 5. 1.6 squared plus 6, 1.6 plus 5, blah, blah, blah. And you keep plugging. You can actually solve them separately in the table if you want, and then plug the answers. And don't forget that you have to plug the last one. And the last one is 4. Let me put it in green color. It's going to be 4, I forgot the function, 4 cubed minus 5 times 4 squared plus 6 times 5 plus 5. That's the last one. B equals 4. Calculate everything and you get a number. Since I'm very, very smart, basically a working calculator, I already calculated. That's a joke, I see it in front of me. 28.96. Meow. My cat is meowing, even though he had food and I cleaned his litter and I pet him. So I don't know what to tell you. Now, quickly, so that actually is the answer. Now, quickly, let's do the, just mentioning the other two methods because the idea is more or less the same. Left endpoint method. For you to know, I don't like putting on a tests midpoint method. Too much work. So left one and right one are good for the tests. L sub 5 will be the same formula. You just need to know that now you start with A. You actually start with f, and you put the very first one in it, x sub 0. So that's the big difference. So that's going to be the first one, A. While before it was the last one, B. Plus la 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 la. And then you don't plug the very right one. So it's going to be x to the 4. Thus, the picture in this case will look like this. Check this out. I'll put it in blue. I'm starting with the first one, but don't go to the last one because we need to have left endpoints. Let me change the highlighter to like this blue. Leftist, the other left, so left is for the first interval, left is for the second interval, left endpoint, left endpoint, left endpoint. And since we already have left endpoint for the last interval, we don't need 4. So that is the whole point here. And guess what? You repeat the whole process. The good thing is you have all the points calculated except the very first one. So you have this, like the second point, the third point, and so on, but you don't need the last one though. So you only need to recalculate the very first point at, not recalculate, calculate from scratch. 0.8, you need to calculate a new point where you plug zero. What was that? 0. That's the easy one actually, because it's a 0 cube. What is my function? Forgot again. 0 cube minus 5 0 squared plus 6 times 0 plus 5. Well, guess what? That's 5. Then the other one we already have. We have it plus have it. 1, 2, 3. So we need how many points? 1, 2, 3, 4, right? So we have the second one. We have, so the check mark, and the one more check mark, and we don't need the last one. And I see in my notes the answer is 2256. 22,56. That's the answer for the left endpoint. Finally, the midpoint is the most annoying one, but it actually gives a much better approximation for most of the cases. Midpoint. The midpoint usually is m sub 5 in American notation, and the idea is the same, delta x, but you plug midpoints here, so something completely different. Like, what are those points? To do that, you have to, well, you don't have to, but I recommend to resketch the interval from A to B, 0 to 4, and you have 0.8, and you have 1.6, and you have 0.8, 1.6, 2.4, and 3.2. And then you have to find the midpoints. You have to find this point, and plug them instead. There will be 5 points. So what is this point? This point is 0.8 minus 0 over 2. It's always b minus a over 2, right? But not this b. It's always next minus first or previous over 2. That's the formula. So the first midpoint will be 0.4. Now 1.6 minus 0.8 over 2. You can still calculating that, or you can be smart and just remember step size is still the same. Delta x is still 0.8. So actually you can just add 0.8 to 0.4, and then you will get the same answer, which is 1.2. Let's check. 1.6 minus 0.8 is 0.8. 1.6 minus 0.8 is 0.8 divided by 2 is 0.4. So does it correct? Oh, it gives you this point. That's why. You need to add. I see. Yeah, now I remember that. You need to add and divide by 2. So that's going to be 2.4 divided by, oh no, that's not correct. Oh, yes, divided by 2, 1.2. So that's how you can find it. But it's easy just to keep adding 0.8, because remember, 0.8 is a step size. That's what you plug, midpoints, and you plug them all midpoints. So you keep adding, and then don't forget to multiply by step size delta x. So we'll have 5 points, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1 is missing, 5. That's it. That's how you do it. The easier the function, the faster calculations are. So just struggle a little bit with midpoints, but for the tests, I highly recommend to practice these two, which is left endpoint and right endpoint, because usually this is what I personally like to put on a test, not the midpoint test. Too much extra calculation, and it's just frustrating. I don't like students getting too frustrated and then they don't do well. What is the point then? To fail students on purpose? I feel like that's just not nice. Thank you for watching. Keep practicing, and I see you next time.